Welcome to 4.3, another form of the equation for a linear relation. Homework questions are on page 178 to 180. Questions number 5, 7, 11, and 12. Okay, so be sure to do these questions. There's also a 4.3 handout that is after all the notes. Okay, so please sure to do this as well. Remember, the answers for these are on the back of the note package. All right, and I do give you some graph here to use if you didn't have graph paper at home. Here's some I already put in for you in the handout to use. Okay. All right, so 4.3. We're gonna look at graphs that look like x plus y, because you're used to seeing y equals kind of graphs. We're going to have it so now you see where y and x are on the same side of the equal sign. Okay, so we're going to see what that looks like. So let's just take a look at first this table. First integer x. Here's their values, -6, -4, -2, all the way through. Here's some y values for the second integer, 9, 7, all the way through. Okay, remember these are points. Right? This is the same as saying this is the point for -6 and 9. This is the point for -4 and 7, and so on. And then we would plot those points. So once we get all our ordered pairs and we plot them, this is what the graph looks like. I don't know if you can see it, but here's the points right here. Okay, the points lie on a straight line. So the relation is linear. It's a linear relation. Linear, this is a straight line. We can write this linear relation as the first integer plus the second integer equals 3, which makes sense, right? Because if we add all of these, -6 plus 9 equals 3. -4 plus 7 equals 3. So we can write it as this. X plus y equals 3. This is a linear relation. Even though it looks kind of different, this is still a linear relation, because if we were to, as we did here, we put values in, it creates a linear graph, a straight line graph. So therefore, it is a linear relation. Now, these could be manipulated to make it look like a y equals graph, or as you'll see later on in 4.4, we can write it as an equation of a line. Now, we could write it so it does look like this, where it's y equals. Okay, sorry, all this dog hair over here. And the way to do this is this. Okay, this 3, it's on the right side, it's still here. I want to isolate y, so what do over here on the left side? I have to minus x on both sides. So if I did that, this would be minus x, and this would be a +3, right? Because it's still a +3. It could look like that, or it could look like this. We could just rearrange these, because in adding, remember, order doesn't matter. I could put this, the constant first, +3, and put the minus x here. Okay? If you do not know how to manipulate and make it look like this, don't worry about it. You'll still be able to do the questions in this. I just want to let you know that x plus y equals 3 can look like this. Y equals -x plus 3, or y equals 3 minus x. Because we just isolated y, right? Minus the x on both sides would cancel out the x on the left side, but it would still be on the right side. Okay. Now, when your linear relation has variables, has both of them, the x and the y, you're always going to get an oblique graph. Diagonal lines are oblique. So whenever you see an equation that has x and y in it, right away it's either going to be a decreasing graph or increasing graph, no matter what, if you see both variables. Okay? Which segues into what happens if there's only one variable in our linear relation. Well, here we go. We're going to show you that right now. X graphs. So very key thing right here, I bolded it. X graphs are vertical lines. Vertical lines. that intersect the x-axis. Intersect the x-axis at any given point A, or any value A. So here's like the big theory part of describing it. The graph of the equation x equals A, where A is constant, any is a value, a constant. It could be a negative number or a positive number or even zero. It is a vertical line where every point on the graph has the x coordinate of the value A. Just means that the x coordinate is always going to be this value A, no matter what. Why is that? It is because if I pick a point on this black line here, the graph here, your x coordinate is always going to be 3 because it's not going left or right, it's just going up and down. So it's always going to be the value where it intersects at. Okay, so in this example, x equals A, we have A equaling 3, so x equals 3. So for the graph, x equals 3, the x coordinate will always have a value of have the value of 3, and the y coordinate can be any value because you're going up and down. It could be 3 and 2, 3 and 5, 3 and a million can go all the way up. Okay. Examples of coordinates for the graph x equals 3. Okay. So remember, this line always has to be labeled, and it's labeled x equals 3. Now let's find some points that are on here. Like I said before, let's go with this one. I pick this point here. This point is 3 and 3. This is your x coordinate, y coordinate. If I pick this one, what's my x coordinate? Well, 1, 2, 3. My y coordinate, it didn't go up or down. It stays neutral at 0. Okay, say I pick this point right here. What's the x coordinate? Well, 1, 2, 3 stays as 3, as we said over here. X coordinate will always have a value of 3. The y coordinate, however, is 1, 2, 3, negative 3. Okay, so remember, x coordinates, vertical graphs intersecting the x-axis. All coordinates, x coordinates on this graph will be the value of where it intersects at. In this example, it intersects at 3, so every x coordinate is always 3. Y coordinates could always differ here. Okay, let's go into the next page. So we looked at x graphs. Now let's take a look at y graphs. All right. So it's basically the opposite of x graphs. Y graphs are horizontal lines. Horizontal lines that intersect the y-axis at A, any value of A. The graph of the equation y equals A, where A is the constant, can be a negative or positive number or even 0. It is a horizontal line where every point on the graph has a y coordinate of A. Okay, so, because remember, if this is my y graph, the y value does not go up or down. It stays at this level. It just moves left or right. So if we look at this example, y equals A, our A value here is equal to 3. For the graph y equals 3, the y coordinate will always have a value of 3 because it's not going up or down. It stays at that level. And the x coordinate can be any value because it could be negative, it could be positive, it could be even 0. Let's find some examples of coordinates for the y equals 3 y graph. So let's pick this guy right here. I already know the y coordinate is always going to be 3. X coordinate, though, is going to be 1, 2, 3, 4. Negative 4. Remember, your y coordinate could be right in the middle here. So this coordinate, I know the y value is always 3. X coordinate, it didn't go left or right, so it is 0. It is neutral. Say I pick this coordinate over here. I know this coordinate is, the y coordinate is 3. X coordinate is 1, 2, 3, 4, 5. Okay. So that's x and y coordinates. Or x and y graphs, sorry. Now let's see if we can graph these given the value of the graph here. So graph the following equation, x equals -4. So let's see x, so this means this is a x graph. Okay, what does x graph look like? X graphs are vertical. A vertical line intersects, okay, it's going to intersect x-axis at -4. So I want to go to my graph, Cartesian plane here, remember. Look for -4 on the x-axis. 1, 2, 3, 4. There it is, right here. I have to draw a vertical line that intersects that -4 on the x-axis. And there we go. Once I do that, I have to label it because I can't just leave it there. I have to know what is the equation of that graph. This is x equals -4. You want to label it because sometimes you might have questions where a whole bunch of graphs are everywhere and you got to know which graph's what, so you have to label it. And there we go. We would describe the graph as a vertical line intersecting the x-axis at -4, which is what I just did here.